Okay, so good afternoon, guys. Um, yeah, so today we're going to be looking at background tasks and work manager, right, in Android. Okay, and these are week 4 of CodeCamp training, Android Intermediate. So yeah, let's just get started. So, like I said, we're going to be talking about background task and work manager. Now, background tasks basically, of course, as the name implies, right? Tasks are run in the background. Okay, they're actually very essential when it comes to Android, right? Android development because they basically just help you to perform operations that doesn't require the user interface to be in the foreground. Okay, of course, you understand foreground and background, right? So they are just operations that you actually run at the background. Okay, the user doesn't actually need to see what is going on, right? But they actually just run in okay, and they can actually range from updates, right? And the essence is just to have this smooth user experience, right? So let's see, maybe it's a typical example. Let's say a user actually wants to um let's look at chats, for example, right? You're on WhatsApp and then you're chatting, right? Now when you actually have a message, let's say you've minimized the application and you have a message come through, right? Now you're currently not in the foreground, but yet that message is able to still come through to you, right? And you understand. So that's basically the essence. So the user doesn't actually need to know that, or doesn't actually need to see how that actually works. The user doesn't have to be in the foreground for that to happen. You must not be the WhatsApp must not be open for you to actually get a message. So that's just kind of like the idea of background task and everything, right? So there are two important libraries that can help you manage background task, right, in Android. And the first one is Job Scheduler, and then you have that was actually introduced in I think Android 5.0. Yeah, and then the second one is Work Manager, which we're going to be talking about. This was actually introduced in the Android architecture components, right? It's part of the Android architecture components. Okay, so let's move. Okay, so first of all, so Work Manager is actually a part of the Android Jetpack, and it provides a simple and consistent API, okay, that helps you to perform background what tasks. Okay, that's as simple as that. So what it basically does, as you can see, it just abstracts that scheduling mechanism. That's mechanism that takes care of some optimizations, right? That is device specific, right? For example, if you can run a task when your phone is charging, right? Or probably when you have a stable network, or probably when you don't actually have a stable network, right? So that's basically where the work manager actually what comes in, right? So let's move on and look at the practical example. So when you want to implement the work manager, which you will, of course, as part of your task when we're done in the notebook application, I'll put that out. So first things first, of course, you should add your dependency, right? But you need to be sure that you have to use the updated one, right? So add your dependency, which is the very first thing you need to actually do. Now, after adding your dependency, the next thing is to create a worker class, right? Next is to create a worker class. So basically, your worker class, you can actually see that here from this example here. You just create a class, you can call it. So this is just an example of, we're just painting a scenario where we're fetching, let's say, a weather API. We're fetching the weather forecast for probably the day or the week or something like that, right? So that's basically just like a test, right? So you create a worker class that takes in a context, and then of course a worker parameters, right? And then you extend the worker class, right? Of course. So the weather worker here is our class name, and then we're extending the worker class that takes a context and some parameters, which we are calling worker params, right? And then, of course, when you extend the worker class, you now have to override the do work function, right? You override the do work function where you can use a try and catch, right? Of course, you can just get your weather. This line here is just to fetch data from an API. Well, not this is not actually an implementation per se, but just of course you actually customize that and do that in the perfect way. And then let's say you want to display weather notification, right, based on the data. And then of course you return what the success, return the results dot what success, because your do work actually returns a result. So is it success or is it failure, right? And of course, your fetch data API, which is here, you've already created a function where you implement an API call to fetch that data and all of that, right? So that's just the first step. So you create a worker class, okay, and then override the do work what function. So in that inside the do work function, right, you use a try and catch, and that's where you capture what exactly you actually want to happen, right, okay, in the what background. Okay, now um let's move on. So the next thing is to schedule the what work, right? That's the next thing. Next thing is to actually what schedule the work. So we use what we call a constraints, right? Constraints.builder, right? So this is an example of a constraint, right? We just set actually using a work manager in the context of when you're fetching data. Sometimes you can actually have we're checking if the device network is connected or not, right? We're checking if the device network is connected or not, right? So that's basically what we're doing here. So we're using the constraints.builder to get the network type, the required network type, and the required network type we actually want to know actually has the connected what status, right? So that's actually just straightforward, right? So basically what we are scheduling this is because we want our weather worker class to run periodically. Okay, we want it to work what periodically. Now like for example, our work request here, we're actually we want to fetch data every 6 hours. Okay, that's why you have the weather work request. You use the periodic work request builder, right, to and then where we pass in the interval. So this is 6. We're passing the interval, which is 6, and then in time unit is hours. So that's 6 hours. And then dots we call the set constraints, and this constraints is what we have defined here already. Okay, so the constraints here is this: we want to schedule our weather worker class to run periodically every 6 hours, as long as the device has network what connection. As long as the device have network connection, then we want to run the what weather worker class, which we have already defined here, right? We want to run this so we want to fetch data every 6 hours as far as there's network what connection. Okay, so that's basically what we're actually doing here. So this first line here gets the network connection, right, our constraints, and then here is the actual what request, which we want to actually do for 6 hours, and then we'll dot set constraints and then build that. And then of course we'll call our work manager dot get instance, passing the context, and then queue it. We now queue it to what actually what run. Okay, so that's actually how you schedule the work. Now, after scheduling the work, you now get to handle the result, because yet you're telling it to run in the background. For example, fetch data after 6 hours, right? So once it does that, what do you want to do with that what result? Okay, how do you want to handle it? So basically you can actually observe the status of your work, right, and take the necessary action, right, when the task either completes or when it actually fails. So a typical example is we're using our work manager here, right, the info to check the status of your work. So we'll just call the work manager dot get instance, pass in the context, and then get the work info by ID live data, of which every weather work request actually has an what ID. So we're basically going to observe that. And if the work info is not null, then we now check the state, because if it is not null, it means that it actually has a value. So what is the state? Is the state succeeded? If it's succeeded, that means the work is completed, and then you can, probably do something, right? Maybe send a notification or something, right? If it's failed, right? It's failed. So you probably can do all this. So there are other states you can actually what handle, right? But these are the two just two basic states: succeeded and failed, of which you can actually perform a particular action that is required, right? Dependent on what you actually want to do. to what achieve, right? That's actually how you use the work manager, right? Now, but another thing is very critical is handling errors, right? Handling errors is, when you're using work manager is actually very crucial because it ensures reliability, right? It ensures reliability. It actually that your code is actually reliable because it kind of gives you, the right information at every point. Okay, so you need to be able to handle errors, right, in your background what task. So this is just a typical example, right? Now you can handle the error within your worker class, which is our do where we overrode the do function, right? So here we're using a try and catch. Okay, so we store the results from fetching the data API, right, in the weather data variable, and if it is valid we display that and then return that this. So the result we return is that the work was successful. If it is not, we return that the work is what a failure. But we don't just end there, we also catch an exception, right? This is error handling. So you catch an exception, right? This is error handling. So you catch an exception in case there's an exception. What do you want to actually do? Well, you can do a lot of things, right? But it's because here we're just doing results.failure, right? What message? Because the thing is this: it may actually throw exceptions, which could be due to network issues or probably invalid data, right? Probably actually searching for a data that's right, which is usually either network or probably invalid data. So you can actually catch these exceptions and then return results.what failure. That basically just indicates that the work has actually what failed, or you can add your own custom logic, right, of what to do, in case of an invalid what data, right? So this is actually handling the error within the worker class. Now you can also handle the error in the observer class, where, right, what we're just doing here, this is just a typical example, right? Scenario, right? So if the worker info is not equal to completed, if it's failed, there's a we call a function called handle work for failure. This is just a custom function which you can create to actually handle a scenario where the work failed. What exactly would you want to do? So in that function, you can decide to notify the user, right, that it has failed. You can decide to log the error, right, or any action at all, right? When the background task fails, any action that you actually prefer to handle, you can actually do that. That's totally up to you, right? Totally up to you. So um yeah, so that's basically that. But before we let's just okay, let's talk about the last one, right? The last part of handling errors, which is retries and exponential backoff. Now the essence of retries, I don't know, of course you have seen, you've probably used browsers and software. You try to log in. In fact, a typical example is Discord, right? So let's say you're trying to log in and then there's no network or something, right? It doesn't just shut down, it keeps retrying after a period of time, right, till once there's a network connection. Even some browsers do it. I think Chrome does it, right? When you're trying to access this and there's no network, right, they just stop. It keeps retrying actually until there's a network, but it does it. There's what called more like an incremental delay, right? It increases the delay in at so probably if you tried it after 6 seconds, probably the next time it will try it again will probably be after maybe 12 seconds. Just an example, right? Now, so to handle what we call transient errors, right, such as your temporary network issues, right, you can actually set automatic retries with exponential what back off using the set back off criteria here, right? This set back off criteria is actually from your periodic work request builder, which we actually passed when we wanted to get our request, right? So basically, this allows the work manager to automatically retry the work with increasing delays between the what retries. So if you did it in 10 seconds, probably the next time it to do it is 20 seconds, probably the next time it to do it is 30 seconds. So the question is why, right? So let's talk about transient errors, right? Now, transient errors basically, they are actually also or intermittent errors, whichever one one is okay. But there are errors that occur temporarily, right? They just occur temporarily, and typically, right, they're actually caused by when there's more like an unpredictable issue in in a system, right? That's basically what actually causes them, or network actually. Now, these kind of errors, right, they are not actually, they don't really indicate that there's a permanent problem or a long-term program. Like for example, you're trying to open a website, and you're using a MiFi, you're trying to log on to Facebook or something, and maybe your MiFi goes off, right? It will keep trying. So Facebook won't open. That doesn't actually mean there's actually a long problem or a permanent issue with Facebook. No, right? That doesn't actually what mean that. So that's the kind of errors. So these are transient what errors, right? They're actually short term, they are short lived, they are transient in nature, right? And they can be caused by a lot of few things, which I'm going to just, this is just kind of like an extra I'm giving you. One of the things that causes them is network issues, right? Network issues. Network issues is one of the things that causes a transient what error, which I think I've already explained. Secondly, could be temporary network outage, right? Because your brief disruptions in network connectivity, right, can actually oftentimes due to hardware changes like maintenance or other transient factors, right? So where we have maybe your laptop goes off, right, or something wrong with your hardware, right, it can actually cause temporary network or outages, which definitely that is also a way to that gives us the whole transient error. Another thing is server overload. So if there's an overload on your in your server, when a server experiences kind of like a sudden surge in traffic or resource demands, right, it can temporarily become overwhelmed, and that will lead to slower response times or even what errors, right? I'm trying to think of there was a scenario, right? Okay, yeah, when ChatGPT actually came out, right? So there are times where you can't actually log in because there's this overload. A lot of persons are kind of trying to get in. In fact, we see a lot of this server overload stuff in, um, in some universities and schools who actually use student portal, right, and hasn't been properly optimized. So you notice that sometimes you can't use it during the day, right? So there are people who log in at night when it's a bit what free. Okay, why? Because there's this traffic. Almost everybody is requesting for a resource, right? So that's server overload, right? Now, another thing that can cause transient errors are what database locks, or what we call deadlocks, right? Deadlocks. Now, in database, right, transient errors can actually occur when you have multiple processes or threads that are attempting to access the same resource simultaneously, right? And this causes conflict, right? Now, the conflict is eventually resolved. Have you noticed sometimes that, let me just use this example, right? That sometimes maybe your laptop is hanging, it just hangs for like, let's say 10-20 seconds, and then it frees up. What's happening? There's a deadlock, right? Multiple processes, one resource is required by a lot of processes. So at that point, if you just do your that what's that, I think that's on Windows, that should be Control Shift Escape, right? That should open up your what's it called, let me just try. There's a name for it. Your task manager, right? You can actually, that can actually, if you go through that, you can actually see that you can see just about like an overview. If you're able to read it very well, you actually see some of the applications that are actually causing that. Now, like I said, the essence is the issue there is one resource, right? Just with, and a typical resource, right, that is almost always, in fact, is your RAM, right? When everything is dragging RAM, like everything wants to use your RAM. Now at the point where everything wants to use it at the same time, you have, that's where your laptops now become slow, right? Reduces the speed and everything, but reduces, right? But eventually it frees up. If you're able to shut down some of these applications, it begins to free up. Why? The demand has what reduced, right? So that's also another cause of what transient what errors, right? Okay, we also have temporary resource exhaustion, right? If your resource, um, you know, there's a constraint in your resource. Let's say your memory is now a bit low, right? I think some months back I downloaded Photoshop, right? And I noticed that when my hard drive is at a particular space memory level, I can't actually run Photoshop, right? You tell me something about disk catch and whatever, right? So when your resource, when there's a temporary resource exhaustion, the size of your memory is a bit low. There are a lot of things you definitely have this kind of what errors, right? So that's just a few of them, right? We're not really talking about all these things. So, but that's basically that about work manager, right? It's something that you need to do. Of course, a lot of times it's dependent on the project you're working on, right? But even the simplest of applications, right? You can also handle, background tasks, right? You can also handle background tasks because they are very, very, actually very, very important, because they are just things that, as we said, they run in the background, right? And the essence of that is to give user a smooth experience. Okay, this I usually tell my students now, right? Just think of this. You guys are the one building applications, right? And you use log cards. You notice that when you're trying to run it with either an emulator or your physical device, but worst of all is your physical device, where you connect your USB, right? And then you check your log card, you see a lot of readings, right? So your log card is showing you a lot of readings, a lot of things that are happening on your phone, right? But let's leave that. If you have worked with network, you have done some API calls, maybe log in and log out. When you click on login, there's something happens. A lot of processes go through, right, before the user is able to log in. Now, imagine showing the user, maybe when a user clicks login, you now show him a terminal and everything is running, the codes, everything. The user is seeing that. After he or she sees it for, like, of course, if network is slow, let's say the user sees it for about 20 seconds before the user is now logged in. That's not a very good experience, right? So the user is not supposed to see that. So instead, what do? We show the user something else, which is what? A progress bar. We just show the user a progress bar, something that just tells the user, okay, hey, something is happening at the background. Okay, don't worry yourself as it's loading. In fact, sometimes we can just use this seek bar, the one that just goes and then it's counting and stuff like. Why? Because we don't need to show the user these things that are happening at the background. They stay there, but we can now give the user a smooth experience. We give the user a user interface that kind of lets the user know that something is actually what's going on at the background. Okay, so as part of your task, yes, in our notebook application, I know you may be wondering, what exactly am I going to even do as a background task, right? I'm going to actually tell you that in the task, but you're going to implement that with the process I've actually stated here. It's actually a very simple process, but I'll let you know what exactly, what's the actual, what exactly the actual task I want you to actually run in the background, right? So that task will be up definitely before 7 p.m. Yes, to be up before 7 p.m. So you can actually, you know, work that out and submit by Sunday latest. Okay. So that's basically that for today. Like I said, from next week, yeah, we'll get into actual coding stuff, right? I just needed to get out some concepts, get them into your head first before we get into the coding, because once we get into coding, we're going to start having 2 hours will probably not even be enough, right? Especially to finish one thing. So I need to be sure that I clear out stuff so that when we start, kind of writing actual codes, right? Things will not be won't have a backlog. Okay, so that's basically that for today. Are there any questions? If there are none, we're going to quickly end the class and then update your assignment on the learning management system. Okay, so I'll take that there's no question. Okay, so thank you very much, guys. We'll meet on Discord. Have a wonderful day.